Let's dive in. Here we are. 10.1, hypothesis test for a difference between two population proportions. So here comes the question. Are freshman psychology majors less likely to change their major before they graduate compared to freshman business majors? What do you think? Who is more or less likely to change their major? I changed my major after 4 years of college. It wasn't a dramatic change, though, from computer engineering to math. So it was pretty much the same those first few years. But anyway, so who's less likely to change their major? We're going to compare here. We're trying to answer a real-life question. We're going to compare psychology majors and business majors, and we're asking who, so psychology or business, who is less likely have another E in there? Yeah. To change their major. That's what they're asking. So they did a study. They did a study on this, and here's how it went. They took 368 of the 602 freshman psych majors, changed their major. That's a lot of them. That's more than half of them. And 470 of 709, that's more than half also, freshman business majors changed their major before they graduated. What can be concluded at the alpha 0.10 level of significance? What can be concluded at the alpha 0.10 level of significance? All right. So how do you compare two different groups? We have something on the calculator that'll do just that. So first off, what is it we're testing on this one? Normally we come down here to like the claim, It's always about the claim. It's going to be the same thing, no difference here. This chapter, hypothesis tests always are all about a claim, an HO, and an H1, so it'll strengthen what you already know. Claim, what do we always write for the claim? Well, normally we write like P is greater than a number, or P is less than a number, or P equals a number, or P doesn't equal a number. Something like that, right? That's normally what we do in a proportion hypothesis test. Well, on this one, there's not just one group, but there's two. So what we're going to do is we're going to say P1 and P2. We're comparing two populations. We're going to let P1 be the psych majors and P2 be the proportion of business majors that change their major before they graduate. This makes sense what I'm doing? So what's new in this chapter is we'll have two groups. P1 is the psych majors, P2 is the business majors. So they're asking, what they said is, they didn't say who is less likely. They said, are the psych majors less likely? I should have written it that way. Let me do that. Let me fix that. Because that's what they said. Are psych, which we're calling P1, majors less likely to change than the business majors, which we're calling P2. So are the psych majors less likely to change? So what do you think I'm going to put right in the middle of P1 and P2? An equal sign? Certainly not. A less sign, huh? Is P1 less than P2? That's what they're asking, huh? Is P1 less than P2? Is the psych major percentage that changes less than the business major percent that changes? All right. So that's what we put right down here. So what do you think the HO is going to be? So there's going to be P1, it's going to be P2, it's going to be P1 here, going to be P2 there. What do you think the HO is going to be in the middle? What is HO always? That will never stop. That will always be the case. So HO still equals, it always will be. It's on tonight's exam, it'll be on the fourth exam, it'll be on the final exam. HO is always equal. What's H1 going to be? less than, because one of them has to match the claim, huh? And we'll write claim next to that one. And how do you think the evidence is going to go? Same way it always goes. Weak evidence for the HO. Strong evidence. That's what you're going to write on tonight's test, right? For your HO and H1. That continues to be the same on that. All right. So now we're going to go to our calculator and crank this out. So let me write for you. Do you guys have, you know where we're going, right? We're going to go to stats, tests, same place we've always been going. As you look at that list there, what do you think? I bet you can figure it out. Which test, we're going to do another one. Remember, I told you we're going to try to finish that whole list of tests in the next 4 or 5 weeks that are on your, when you go to the calculator and you hit stats and tests. 2 prop Z, because we have 2 proportions, huh? So it's going to be the 2 prop Z test, exactly. You guys don't need me up here lecturing this. You can figure this out now. 2 prop Z test, exactly. That's where we go on the calculator, because we have 2 proportions, P1 and P2. We're doing a hypothesis test, so 2 prop Z test. Yeah, so what we get, let me see, I've got to have some little more room for that then. I'm going to bring it over here. So 2 prop Z test, and it's asking for X1, N1, X2, N2. Yeah. Okay, so what do you think is going to be X1 and N1?
Psych majors.
Yeah, it's getting the information right here about the psych majors, right? Which is, 368 out of 602 psych majors. So 368 out of 602, that's the N, that's the total psych majors. And then the next 2 numbers, 470 and 709. 470 and 709, they're the X2, N2 because they're the number of business majors, right? And the 1, X1, N1, that's P1, that's going with psych, and X2, N2, that's P2 going with business. So it's just like you would expect, and then down below it's got greater than, less than, not equal. So we know what we do there. What are we going to put in? Yeah, same as H1, like always. Just grab what's in H1. Hit enter, and that should do it. I'll do it too. Let's see what numbers we're getting. And calculate. So I got a Z test statistic that is negative 1 point, what's 3 decimal places? 939. Y'all getting that? And a p-value that is, what does it want, 4 decimal places, 0.0262. 0.0262 on that. Are we good there? All right, and so you know how we do these tests, right? What do we always do to draw a conclusion for a hypothesis test? It's all the same as what you're going to do in tonight's test. Got to compare it to the significance level, right? So we've got the p-value. Let me bring it over here. So we've got a p-value that's 0.0262, and then we got to grab the significance level. What's the significance level on this one? Right there, right? 0.10. 0.10. Okay, so which one's bigger, the p-value or the significance level? Can you tell? It might help to add a couple zeros. That way they're more easily comparable. They have 4 decimals. So which one's bigger? Yeah, the 1,000 is bigger than 262, huh? 10% is bigger than 2%, right? All right, so that's the way, right? The wide side goes towards the significance level. That one's bigger. So is the p low or not low? Yeah, the p is less than. It's low, isn't it? So P is low, which means what? You guys know this. You'll never be able to forget it, maybe. Maybe after a long time you'll be able to forget it. But if the P is low, we're going to do it for 4 more weeks. If P is low, HO must go. Go where? Go away. Be rejected. That's what that means, right? So if the P is low, the HO must go away, be rejected. So I'll go back up and I'll cross off the HO. It's rejected, huh? Just like all the hypothesis test conclusions. So what do we conclude is true then? The other one, right? H1, which is this and all of this. So H1 is true. So we believe H1. We crossed off HO. We rejected the HO. So we believe H1, which says P1 is indeed less than P2, as claimed, and the evidence is strong. That good? So now we'll be able to follow the right words. So is it the first one there? The results are statistically insignificant. Are they insignificant? No, they're strong. They're significant. So how about the next one? The results are, no, those both say insignificant, don't they? So let's go to our fresh screen here. I'm going to bring our stuff over. Let's see, it's P1 equals P2, P1 less than P2, and it was, what was it? It was, the claim was here on this bottom one, and evidence was strong. So he's strong on the bottom one, weak on the top. And we rejected the null, so we rejected that one. And so we're accepting the H1. And so, how about the third one? The results are statistically significant. Yes, they are. So there is sufficient evidence. Yeah, but this says the same thing. So far the same. Conclude that the population, proportion of freshmen. Which one of those is right? Those are really similar. What do y'all think? We'll call them C and D. This will be our first multiple choice question of the evening. What do you think, C or D? They're pretty close. Want me to read it? So C says, to conclude that the proportion of the 602 freshmen psych majors who change their major is less than the proportion of the 709 freshmen business majors who change their major. And D says, to conclude that the population proportion of freshman psych majors who change their major is less than the population proportion of freshman business majors who change their major. What do you think? Is that making any sense? Anybody feeling it? Which one's the right answer? Bottom one? Zach, bottom one? Why is that?
Because the numbers, those are the total of the people they asked versus the actual people who said they were changing their major. Am I right there?
This is the total people they asked?
I thought so.
Right, it is. But they said the proportion of those people.
Fair enough.
You know what we're doing? You're getting stumped on because you're staring at the trees and you're forgetting we're in a forest. You know that old saying? Don't miss the forest for the trees.
No.
This isn't about. You never heard that saying?
No.
Really? Oh. Don't miss the forest for the trees. Right? You can be so micro focused, looking at the bark and the real, and then you forget. Where's the forest? I don't know. And you're just staring at the tree. You're in the forest. So in other words, remember, this isn't about nitty gritty details. This is about what is a confidence interval. Like, what are we even doing when we're doing a confidence interval? Right? Think with me for a second. If I was to say, hey, you guys are about to take exam number 3, I'm going to guess that you're going to average 80%. I hope so. I hope your average will be, I think this will be an easier exam, and your average, the class average might be 80%. That's a hypothesis test, confidence interval. It's a hypothesis test, is what it really is. I have a hypothesis that your average will be 80%. Anyway, what am I guessing at? What the true average might be, huh? You see, it's this one. I can't circle. It's this one. That other one is baloney because they're talking about the 602, 709. Not that those are the wrong numbers, but we don't care about numbers at all like that. Remember what we're doing? We're not trying to figure out how many of the 609. We're trying to figure out how many overall, what the overall truth is for psych majors and business majors. Remember what we're doing in a hypothesis test? We're always trying to get the truth of everything. Does that make sense? Maybe I'm not making. I'd be like this. Let me do a polling example. What if they started polling next year before the 2020 election, and they said, "Hey, we really think that 30% of Fresno County or some area is going to vote for this certain candidate." Who cares? We don't really care about that. What we care about is what the nation's going to do, huh? The big picture. Well, that's what's going on here. This is silliness. We're not trying to figure out what the 602 people did. We're trying to figure out the population proportion, meaning for the whole population. That's always what a confidence interval is. It's the truth of the whole thing. This is a sample, right? You use the sample to learn the truth about the whole population. That making any sense? All right, so there's our right answer on that one. We good there? Question? Shall we try one? Here's number 2. Let's try one of these and see how you're doing. Is the proportion of wildfires, very appropriate timing, huh? Wildfires caused by humans in the south different from the proportion of wildfires caused by humans in the west? So we're going to let P1, so you always have P1 and P2. We're going to let P1 be the percent of wildfires caused by humans in the, where is it? In the south. South. And we'll let P2 be the percent of wildfires caused by humans. I just don't have room to write all those words. In the west. So that's the two. So you're always going to have two groups on these. Those are the two groups we're talking about. Percent of wildfires in the south, percent of wildfires caused by humans in the west. Are most wildfires caused by humans? Probably. Not caused by bears usually, are they? I don't know. Natural causes, I guess. But anyway. So, all right, so let's go on. So what are they actually asking? Is the proportion caused by humans in the south different? Is the south different from the west? So in the south, is there a different amount of different percentage of forest fires caused by humans than in the west? So what is that claim? How do we write that claim? Let me help you. So with the claim, on all these problems in Chapter 10, there's always going to be two proportions. So P1 and P2. Rather than just a single P or a single mu, it's going to be a P1 and a P2, or, next time, mu1 and mu2. And you're going to put in the middle either equals or greater or less or not equal. So what do you think? What are we going to put in the middle of that P1 and P2? Different? What is different?
Not equal.
Not equal, huh? If two things are different, then they're not the same. They're not equal. Is that good? So then what do you think? And now remember, HO and H1, that'll be P1, P2. Same kind of thing. And what's HO going to be? What's HO always? Always equals, huh? HO is always equals. And so what's H1 going to be? Not equal. Because one of them has to be the same as the claim, huh? See how similar this is? This is hardly not any different at all, is it? It's just two proportions instead of one, but everything's the same. The word different. So if you have different on tonight's test, that means not equals, huh? Even for one proportion. Same thing. Different means not equal. So which one's the claim, HO or H1? H1 is the same as the claim. And you know what we write? We write weak evidence and strong. So I'll write that. Weak evidence, strong evidence. Then we come on down for the test statistic, and so we go to our calculator, and what are we going to do? What's the test on our calculator? We go to stat, test, and what are we going to grab? 2 prop z test. Yeah, because now we have 2 proportions instead of 1, but everything's pretty much the same. It'll ask you x1 and n1. So it's the first population's x and n, and then a second population's x and n. All right, so can you put those in and crank that out? What's our x1 and n1? Yeah, 406 and 577. And the x2 into 433 597. Put all those in. And it's a not equals, right? So choose the not equals option and calculate. I'm getting a z equal to negative 0.821 and a p-value equal to 0.4114. All right. So then, you know how we draw the conclusion? What am I going to do? I'm going to put the p-value here. And what are you going to do tonight whenever you got a p-value and you're wanting to draw a conclusion? Compare it to the sig level, significance level. And the significance level is 0.01. So which one of those is bigger? You can add a couple of zeros there if it helps, so they're more comparable. Which one's bigger? The p is a lot bigger, huh? So is that p low? No, that p's greater. He's not low. So p, when p is not low, HO does not go. Does not go away is what we mean. So P is not low, the HO does not go away. So what does that mean then? If HO does not go away, what do we do with HO? We keep it. Whoops, I'm circling the claim. That's not good. We're keeping HO, aren't we? With all that it says, and we're rejecting the other guy, the H1. Is that good? Because HO does not go away. So that's going to be fail to reject HO. Fail to reject the null. Is that good? Is that making good sense? We're going to fail to reject. We keep the HO, right? If the P is not low, the HO does not go. So, all right, so which of those 4 paragraphs are saying that? Results are statistically insignificant. Is that true? Are they insignificant? Yeah, up here, weak evidence, right? See how I circled HO? Evidence is weak. Evidence is indeed weak. Statistically insignificant, that's right. But there's another one that says that also. There's 2 of them that says statistically insignificant. So, we've got to read the rest of it, huh? Let me get this out of the way. So, there is statistically significant evidence. Is there? No. So, there is insufficient evidence. Yeah, there we go. That's all we need. We can tell the right answer. How we doing? That easy enough? There's not much new here, is there? That's what's kind of nice. Now that you got the foundation for a hypothesis test, it's pretty much just that same kind of thing. They'll just throw a little bit here, a little bit there, 2 populations, not much different. Little different tool on your calculator, but same basic ideas. All the ideas, you've got them. Questions on that one? So here's number 3. The director of student services at Oxnard College is interested in whether women are more likely to attend orientation than men before they begin their coursework. What do you think? Are women more likely to attend orientation than men? Is that what you think? I think so too. Right? Men are just more like, whatever. I know that's how my wife and I are. She's by the book, do it right. And I'm just like, whatever. I'm always like, those people at that thing, they just want you to come because they want to waste your time going to that thing. I'm always like, you're supposed to go to the thing. Like, well, my kids got into the colleges, Fresno State and Cal Poly, and my wife went there with them to the first day thing. I'm like, oh, you don't need to go to that. It's just their blah, 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 blah. You don't need to go. Anyway, so yes, I think probably this is true. It's true in my little home. So, okay, so probably, let's see what the data says. So we're going to compare men and women on whether they go to the orientation for something. Random sample freshmen, so I guess it's college orientation, yeah. So what can be concluded at the 0.10 level of significance? Okay, so let's give it a try. So we're trying to compare whether men or women are more or less likely. Well, what particular is their claim? Maybe I better be a little more careful. Did they make a claim? Did they say that? Oh yeah, you're right. They did. Women are more likely to attend. Okay, they did. Women more likely. Well, here, let's put it up here. More likely to attend. Okay, that seems like it's probably the case. Okay, so women are more likely to attend. All right, that's the claim. So let's write that then in terms of math stuff. So we're going to have a P1 and a P2. P1 will be the women. Oh, I should have said than men, huh? Than men. More likely than men to attend. So P2 will be the men. So what am I going to do if women are more likely? That's more. It's just that straight ahead, isn't it? So you could do this without me even saying a word. No. So P1 is the men. No. P1 is the women. P1 is the women. P2 is the men. And they're saying the women are more likely. P1 is greater than P2. That's the claim. Let's see if the evidence backs that claim or if not. So you know what to do. We come down here to the HO. That's going to be P1, P2 equal, because it's always equal. The H1 is P1 greater than P2, because one of them has to match the claim. So that'll be the claim. You know the deal with evidence. The top one, the HO, is always weak evidence. The H1 is always strong evidence, like that. And, all right. So now, what are we going to use on this one? We're one prop Z test again, huh? So I'll put it over here. Or two. My mistake. Two prop Z test. And then it asks us for X1, N1, X2, N2. This might be a little more challenging. Probably not much for you. X1, N1, X2, N2. So what do you think? Now, this might be a little more tricky. Can you do that real quick? Maybe I better give you a second. Right? Yeah. So you gotta get the ends. Don't you? Gotta come over here and get in. And for women, you just gotta add that up. What is that? 643 total women. 400 said yes, they went to the orientation, and 243 said no, and they didn't go to the orientation. And then for the men, we gotta add them up. So what's that going to be? I can't do that. 688 total men. Right? Some yes went to the orientation, some no, didn't go to the orientation. Yeah, so you got to get those totals, huh? And so this is the N1 and this is the N2 because the women are the 1 and the men are the 2. So this will be the 643 and the 688. And what's the X1 and the X2? Is it the yes numbers or the no numbers? This is good for tonight's test. Yeah, how do you always know? It's whatever they claim. What are they claiming? Likely to not attend? No, to attend, huh? So it's a yes. That makes sense? So watch that on tonight's test too. You know, whatever they're stating in the claim, that's what you plug into your calculator. So if they said, men are more likely to not attend, then I'd be grabbing the no numbers, wouldn't I? Not attend. But they said women are more likely to attend, the yes numbers. Grab the 2 yes numbers. So the yes for women, 400. Yeah, that goes right there. And the yes for men, oops, going the wrong place here. The yes for the men, 415. And this one is a greater, so we just do greater. The rest is pretty simple. Just hit the buttons on your calculator. Okay, so when I did all that, I got a test statistic Z equals 0.707. It rounds to 7. And I got a p-value, 0.2391. No, 99. 0.2399, isn't it? I'm not seeing it very well. 2399. Y'all getting that okay? So then how do we draw a conclusion? What do we always do with our p-value to draw a conclusion? Compare it to the significance level, yeah. So compare that to the significance level, 0.23, write it over here. So the p-value, 0.2399, and the significance level is somewhere, right there, 0.10. 0.10, so I'll add a couple zeros so they're more comparable. So which one's bigger? Yeah, the P's quite a bit bigger. So is that P low? No, that P's not low. That P is definitely not low. So I think we have a fresh screen here. Yeah. So I'll go back over here. So this is P1 equals P2. P1 greater than P2. We got a p-value of 0.2399. And the p-value, 0.2399, is greater than the, significance level of 0.10. So the p is not low, right? P is not low. So the HO does not go away. P is not low, the HO does not go away. So that means I'm keeping the HO. And, I forgot to write weak evidence. Weak evidence. That means evidence is, HO is always weak evidence. So HO does not go away. I fail to reject the HO. So what does that mean in here? The results are statistically significant. Are they significant? No, the evidence was weak. So that's not right. Yeah, here it is, insignificant. And this one's wrong. And insignificant. So those two, it's either the second one or the fourth one. Next it says there is insufficient. And this says significant. So that's wrong. So there we go. Just like that. That was easier. They were all easier than that first one. They were real tricky on that first one. Is that good? This is pretty easy, isn't it? Not too bad? Just 2 populations. All the rest is the same. Now that you know how to do hypothesis tests. Questions I can answer?